Good afternoon and welcome to the video for the 2020 Level 3 Differentiation paper for Level 3 Calculus. So I don't actually have the marking schedule for this paper, so anything I do here is not actually 100% sure in terms of the marking and in terms of what grade it's going to get, but I'm just going to try my best to go through this paper right now. So Level 3 Calculus Applied Differentiation Methods in Solving Problems. Question 1a. Differentiate y equals to 3x minus x squared to the power 5. So for this question, we're going to be using the chain rule. So in this case, we're going to have dy over dx. We're going to take the power down, or in this case, multiply by the power, which is 5 at the front, times 3x minus x squared. Take the power down by 1, and then multiply by the inside function, which in this case is 3 minus 2x. And since we don't have to simplify our answer, we can just leave it like this. And this will definitely just be an achieve level question, okay? This is achieve level question. Question B, find the gradient of the tangent of a curve y equals to 3 sine of 2x plus cos of 2x at the point where x equals to pi over 4. So in this case, we're going to be differentiating, and then we're going to find the gradient by plugging x equals to pi over 4 into our gradient function. So we're going to differentiate, so dy over dx is equals to, so for this 3 sine 2x, we're going to be using the chain rule. So sine goes to cos, so we have 3 cos of 2x multiplied by the derivative of the inside function, which is 2, so we need to multiply by 2, and plus of 2 cos x, so the derivative of cos, it goes to negative sine, and then we need to multiply by the 2, so that gives us negative 2 sine of 2x. So dy over dx equals to 6 cos of 2x minus 2 sine of 2x. Alright, so now we're going to plug in x equals to pi over 4, so dy over dx equals to 6 cos of 2 times pi over 4 is pi over 2, minus 2 sine of pi over 2. Remember, your calculator needs to be on radians mode, okay, not degrees, radians mode, so cos. Right, I should be getting our answer of negative 2 here, so dy over dx equals to negative 2, and that should be giving us a achieve level grade as well here. Question C. Find the value of x for which the graph of the function y equals to x over 1 plus ln of x has a stationary point. So a stationary point, that means that dy over dx equals to 0, because we have a moment when the gradient is 0, so dy over dx equals to 0, so that's a stationary point. So we've got to differentiate again, so we have y equals to x over 1 plus ln of x. So we're going to be using our quotient rule here, so dy over dx. So we're going to differentiate our numerator, so we have derivative of our numerator, so the derivative of x is just 1, multiplied by the denominator, which is just 1 plus ln of x, multiplied by 1, minus the derivative of 1 plus ln of x, which is 1 over x, multiplied by x, and divided by the denominator squared. So that's our gradient function here, so dy over dx equals to 1 plus ln of x, minus x over x, which is just minus 1, all over of 1 plus ln of x squared. Right, so we're going to find the point where dy over dx equals to 0. So therefore, ln of x equals to 0. And therefore, we can see that x equals to 1, because ln of 1 is 0. Or you can just rearrange this to say x equals to e to the power of 0, which equals to 1. Alright, for this question, this should be a merit level question, and in terms of getting your final answer, that should be a merit grade, and an achieved grade should be a correct derivative, okay? So correct derivative in non-simplified form should be enough for an achieve, so achieved up to this step here. Question D, a curve has the equation y equals to x squared cos of x. So show that the equation of the tangent of a curve at the point pi, negative pi squared is y plus 2 pi x equals to pi squared. So this is a show question, so it's trying to show that the equation of the tangent is y plus 2 pi x equals to pi squared. So in order to find the equation of the tangent, we need to find the gradient of the tangent at this pi and negative pi squared point, okay? So first thing we're going to do is going to differentiate this function. We're going to be using the product rule, okay? So we have two functions multiplied together, so that's our f of x, and this is our g of x. So y equals to x squared cos of x. So therefore, dy over dx equals to 2x cos of x. And then we're going to be adding on the derivative of cos x times x squared. So the derivative of cos x is negative sine x, so plus negative sine x times x squared. So dy over dx equals to 2x cos of x minus x squared sine of x. Alright, so now we're going to be substituting the point pi and negative pi, we're just substituting pi to find the gradient. So that's our x points. Dy over dx equals to 2 pi cos of pi minus pi squared sine of pi. Alright, so cos of pi, you should find that gives you a negative 1. And so this will give us negative 2 pi. So our gradient is equation is in the form of y equals to mx plus c. So therefore y equals to negative 2 pi x plus of c. And we know that the equation of the tangent is, we know that the tangent passes through the point pi negative pi squared. So we're going to substitute that point in to find our c value. So we have our negative pi squared equals to negative 2 pi times of pi plus of c. And therefore negative pi squared equals to 2 pi squared, negative 2 pi squared plus of c. Therefore c equals to just pi squared. Okay, so now we have y equals to negative 2 pi x plus of pi squared. And if we move the negative 2 pi x to the other side, we'll get y plus 2 pi x equals to pi squared. And that is our final answer, okay, and that should be a merit level question. In terms of getting an achieved grade, is usually just the correct derivative should be enough to get you an achieved. So correct derivative will get you an achieved grade. Question E, a cylinder of height h and radius r is inscribed as shown in the right inside a sphere of radius 20 centimeters. Find the maximum possible volume of the cylinder. So in this case, so we're just going to write down our volume for the cylinder first. That's given as volume equals to pi r squared h. So in this case, we have variable r and h. So in order to find, we need to find one variable in terms of the other, so we can differentiate with respect to that one variable. So in this case, we can see that the radius of the sphere is 20 centimeters. Therefore, if I drew a line, dotted line from corner to corner, this will be the diameter of the sphere since it's going from the opposite sides of the sphere. So we have 40 centimeters here. Since that's 2 times diameter equals to 40 centimeters. We know that this is 2r, the base here is 2r since that's 2 times the radius, and we know that this height here is h. So therefore we can make an equation using Pythagoras Theorem, so that's h squared plus 2r squared equals to 40 squared. Therefore h squared plus 4r squared equals to 1600. In this case we can make r squared the subject, so we can plug in r squared into a volume equation. So if we do that, that can save us the mess of doing square roots, because square roots increases our chances of making a mistake. So we can just say that 1600 minus h squared over 4, r squared equals to everything on the right hand side here. So r squared equals to 400 minus h squared over 4. So now we can plug this r squared back into our volume equation. So volume equals to pi times of r squared, which is 400 minus h squared over 4, multiplied by h there. Alright, so now we're just going to expand and simplify. So volume equals to 400h minus h to the power 3 over 4. So volume equals to 400 pi h minus pi h 3 to the power 4. Alright, so now we can differentiate with respect to h. So dv over dh equals to 400 pi minus 3 pi h squared over 4. Okay, so now at the maximum volume, so at maximum volume, dv over dh equals to 0. Okay? So therefore 0 equals to 400 pi minus 3 pi h squared over 4. So 3 pi h squared over 4 equals to 400 pi. So pi and pi cancel out here, and we'll see that 3 over 4 h squared equals to 400. 3. Alright, so h squared equals to 1600 over 3. So therefore h equals to plus or minus square root of 1600 over 3. But since h is greater than 0, so h is not equal to negative of square root of 1600 over 3, Alright, so now we're going to plug in this h value back into our volume formula in order to find our volume of the sphere, so not sphere, of the cylinder. So volume equals to pi times 400 minus h squared, which is 600 over 3 over 4, times of 40 over root 3. So just calculator work here, so 400 times 4. Alright, so we should be getting the volume equals to 19,347.19 centimeters cubed. And that's our final answer for this question. Okay, so that's 19,347.19 centimeters cubed, and that is an excellence level question. In terms of getting a merit level question, in terms of getting a merit grade, it's usually finding your h value. So if you can find your h, or if you worked with r, you can find your r value. That will get you a merit. So h here will get you a merit, and achievement will probably be achieved could probably just be up to here if you can differentiate everything correctly, but not solve for h. You might get an achieved there. Alright, so there's that. Question 2, differentiate y equals to 10x over x cubed. So in this case, we're going to be using the quotient rule again here. So y equals to 10x over x cubed. The derivative of 10x is secant squared x. So we can say dy over dx equals to, dy over dx equals to secant squared of x multiplied by x to the power 3 minus the derivative of x cubed, which is 3x squared times 10x, all over x to the power of 6. And you can actually simplify this a little bit, but you don't have to. But if you were to simplify it, you'll get dy over dx equals to secant squared x minus 3 10x all over x to the power 4. So that should get us an achieved level grade. So what I just did for simplifying, I just cancelled x squared on the numerator and denominator. That gives us secant squared x minus 3 10x over x to the power 4. Alright, question B. The value of a car is modeled by the formula v equals to 17,000 e to the power of negative 0.25 t plus 2,000 e to the power of negative 0.5 t plus 500 for t is between 0 and 20 years. And calculate the rate at which the value of the car is changing when it's 8 years old. So these types of questions is really just finding the derivative and then plugging in t equals to 8 to find the rate of change of the price of the car at that time. So if we're going to differentiate, we're going to say dv over dt. That equals to negative 17,000 times the derivative of the power of e, which is just negative. We already put the negative there, so it's just 0.25 minus 0.5 times 2,000 e to the power of negative 0.5 t. So I forgot about the e there, so 0.25 t. Sorry, let me try that again, sorry. Alright, so times 0.25 times e to the power negative of 0.25 t minus 2,000 times 0.5 e to the power of negative 0.5 t. And the 500 just goes to 0 when you differentiate. Okay. So now we can simplify this a little bit. So negative 17,000 times 0.25. So get dv over dt equals to negative 4,250 e to the power of negative 0.25 t minus 1,000 e to the power of negative 0.5 t. So now we substitute t equals to 8. So negative 4,550 e. Alright, Alright, so you should be getting negative 593.49, so that should be dollars per year. So the car is losing $593.49 per year in value. That's the rate of change when the car is 8 years old. Alright, so that should give us an achieved level grade. So achieved here as well. Question C, find the x-coordinates of any stationary point on the graph of the function f of x equals to 2x minus 3, bracket e to the power of x squared plus k. Alright, so once again, stationary points, that means dy over dx equals to 0. Okay, so we need to find the derivative. So first we can expand it out a little bit. We can say f of x equals to, or we don't have to, we can just do it like that actually. So we can just use the product rule straight away. So in this case we have f dash of x equals to, so derivative of 2x minus 3 is just 2. So we have 2 e to the power of x squared plus k. And the derivative of e to the power of x squared plus 2k is just plus 2x times 2x minus 3 e to the power of x squared plus of k. Alright, so we know we can now factor out e to the power of x squared plus k. So f dash of x equals to e to the power of x squared plus k. 2 plus 2x minus 3. Right, so now we know that since e to the power of x squared plus k can never be equal to 0, since there's an asymptote at y equals 0, so therefore this can never be equal to 0, so we can just disregard it as a solution. So therefore for f dash of x equals to 0, so f dash of x equals 0, therefore 2 plus 2x times 2x minus 3 equals to 0. So therefore we'll get 4x squared minus 6x, 4x squared minus 6x plus 2 equals to 0. And just plug into a graphics calculator at this point, so should be getting x equals to 1 and x equals to 1/2. And that should be our final answers for this question, and this should be a merit level question, and a correct derivative should be achieved. Alright, so question D. A rocket is fired vertically upwards. Its height above the launch point is given by the formula h of t equals to 4.8 t squared, where h is the height in meters and t is the time in seconds from firing. An observer at point A is watching the rocket. She is at the same level as the launch point of the rocket and 500 meters from the launch point. Find the rate at which the angle of elevation at A of the rocket is increasing when the rocket is 480 meters above the launch point. Alright, so first things first for these rate of change questions. First thing is that you write down what you have. So we have that h of t is equal to 4.8 t squared. And therefore we can actually find the derivative. And if you find the derivative, you actually get dh over dt equals to 9.6 t. To find the derivative. Okay, so now we need to write down what we need. Okay, so what we need is the rate of change of this angle theta. So that's the angle of elevation. So we need to find d theta over dt. So therefore we can say d theta over dt equals to dh over dt. We need to cancel out dh, so we put dh at the bottom here, and we need to introduce d theta. So that's what we're trying to find here, so d theta over dh. And since we know that this is h, we can say that we can find an equation in terms of theta and h using our Pythagoras rules. So therefore we can say tan theta equals to h over 500. Therefore, h equals to 500 tan theta. So right now we can find dh over d theta. So dh over d theta equals to 500 secant squared x, which equals to 500 over cos squared theta. Not x, sorry. 500 over cos squared theta. So therefore, if we want to find d theta over dh, we find the inverse. So that's d theta over dh equals to cos squared theta over 500. Alright, so looking here, so now we have d theta over dt equals to dh over dt times d theta over dh. So we know that dh over dt equals to 9.6 t. And we know that d theta over dh equals to cos squared theta over 500. Alright, so now we can multiply them together to get d theta over dt. So this will give us 9.6 t multiplied by cos squared theta over 500. Alright, so now to find the rate of change of the angle of elevation, we need the time at this point, and we also need the angle of elevation at this point, okay? So the information we get is that, what information do we get? We get that the rocket is 480 meters above the launch point, so that's h equals to 480 meters. Alright, so how we're going to do this is we're going to find out how long it takes for the rocket to reach 480 meters and what is the angle of elevation at 480 meters. To find the angle, that's pretty easy. You can just say that h is 480 meters, and we can use our Pythagoras theorem in order to find out our angle. So in this case, our angle can just be tan theta equals to 480 over 500. Therefore, theta equals to tan inverse of 480 over 500. And remember to put your calculator on radians. Okay, so the markers are looking for answers in radians. So remember that. So that should give us theta equals to 0.765 radians. Okay. And in terms of the time, we know that h of t equals to 4.8 t squared. So if we substitute 480 into this formula, we'll find our time. So therefore, you find t squared equals to 100. So therefore, t equals to plus or minus 10. But t is obviously greater than 0, so t is greater than 0. Therefore, t equals to 10 seconds. Alright, so now we have all our information. We have t equals to 10 seconds, and we have our angle. So now we can find our rate of change of the angle of elevation. So d theta over dt equals to 9.6 times 10 cos squared of 0.765 all over 500. Let's see what we get here. So alright, so we should find that this gives us an answer of 0.01 radians per second. Okay, so that should be our final answer for this question, 0.01 radians per second. And this should, okay, so this was, if it was a merit, it's either merit or excellent, I don't know, but if it was a merit level question, this would be a pretty challenging merit level question. But if it was a merit level question, then this will be a merit for the final answer. And achieved will probably be finding d theta over dt will probably be enough to score you in achieved. Yeah, this should be a merit level question since they usually do a achieved, merit, excellent. So question E should be the excellence question. So a curve is defined by the parametric equations x equals to ln of t and y equals to 6t cubed, and t is greater than 0. The point P lies on the curve, and at point P, the second derivative equals to 2. Find the exact coordinates of point P. Alright, so first things first, we need to find the second derivative, and we can only find the second derivative if we find the first derivative. Okay, so we're going to work one step at a time. To find the first derivative, we need to take the derivatives of each of these with respect to t. So we find dx over dt, that will give us 1 over t, and dy over dt will give us 18t squared. So dy over dx, that equals to dy over dt multiplied by dt over dx. dt over dx, that will give us 1 over t, which just gives us t. So therefore, dy over dx equals to 18t squared times of t, which equals to 18t cubed. Right, so that's our dy over dx. And in terms of our second derivative, so that's our second derivative, that equals to the derivative of ddt of the second derivative, which is dy over dx, multiplied by dt over dx. Okay, so that's our second derivative. You should find it on the formula sheet. So we need to take the derivative with respect to t of the first derivative and multiply by dt over dx, which is t. Therefore, d squared y, so second derivative, equals to the derivative of 18t cubed, which is 54t squared, multiplied by dt over dx, which is t. So this gives us 54t to the power 3, okay? And we also know that at point P, the second derivative is 2, so we're going to substitute that in to find the t value at this point P. So therefore, 2 equals to 54t cubed. And therefore 1 over 27 equals t cubed. Therefore, if you take both sides to power 1/3, you'll find that t equals to 1 over 3. Now, so that's our point t. So t equals to 1 over 3. And now we need to find the x coordinate and the y coordinates. And all we need to do is substitute t equals to 1 over 3 in each of these formulas. So at this point, x equals to ln of 1 over 3. And at this point, y equals to 6 times of 1 over 3 to the power of 3, was it? Yes. Right, that gives us 2 over 9. Okay, and since we want the exact values, exact coordinates, we're just going to leave out x as ln of 1 over 3. Therefore, the point P is ln of 1 over 3, 2 over 9. And that should be our final answer for this question, which should give us an excellence level grade. In terms of getting a merit level grade, if you can find your t equals to 1 over 3, should be enough to get you a merit grade. So t equals to 1 over 3 will get you a merit. And if you want an achieved grade, you probably need to find the first derivative. So first derivative is always should be enough to get you an achieved grade. Alright, so question 3. Differentiate y equals to 3 ln of x squared minus 1. So for this question, dy over dx, that equals 2. Derivative of the inner function is 2x, so 3 times 2x. Derivative of ln is 1 over everything inside the inner function, so this multiplied by 1 over x squared minus 1. This gives us 6x over x squared minus 1. And that should be just an achieved level question. For what values of x does the tangent to the graph of the function f of x equals to 2x minus 2 root x, where x is greater than 0, has a gradient of 1? So gradient of 1, we're trying to find the values of x for the gradient of 1. So we need to find the gradient function and substitute the gradient as 1 to find the possible x values that have this gradient. So f of x, we can actually write this as 2x minus 2x to the power 1/2. So therefore f dash of x, we can just use our power rules here. So f dash of x, that equals 2 minus 1/2 times of 2 is just 1, and so minus x to the power negative 1/2. So therefore f dash of x equals to 2 minus 1 over root x. Right, so now we need to substitute f dash of x equals to 1, and so we can find all the possible values of x for when the gradient is 1. So 1 equals to 2 minus 1 over root x. So therefore 1 over root x equals to 1. So therefore 1 equals to root x. So therefore x must be equal to 1. Okay. So x should be equal to 1. Okay, so square root of 1 is still 1. So x equals to 1. X cannot be negative 1 because square root of negative 1 is actually imaginary number, it's actually I. So that's not valid. So x equals to 1 is our only solution, and that should be giving us a achieved level grade. Question C. The normal to the graph of the function y equals to square root of 2x plus 1 at the point 4, 3 intersects the x-axis again at point P. Find the x-coordinate of point P. Right, so we need first things first, we need to find the gradient of the normal at the gradient of not the normal. So gradient of the normal, but then in order to find the gradient of the normal, we need to find the gradient of the tangent, and to find the gradient of the tangent, we need to differentiate. So we know that y equals to square root of 2x plus 1. So y equals to 2x plus 1 to the power 1/2. Therefore, dy over dx equals to 1/2 of 2x plus 1 to the power of negative 1/2 times the derivative of the inside function. Derivative of 2x plus 1 is 2. So this gives us 1 over square root of 2x plus 1. And we know that it's the point 4, 3, so we're going to substitute x equals to 4 to find the gradient of the tangent at x equals to 4. So dy over dx equals to 1 over square root of 8 plus 1, which is 1 over 3. So that's the equation of the tangent. To find the equation, the gradient of the normal, we know that since the normal and the gradient are perpendicular to each other, and perpendicular lines have the gradients, they multiply to negative 1. So we can say that the gradient of normal multiplied by gradient of tangent, that equals to negative 1, okay? So 1 over 3 times m equals to negative 1. So therefore, our m value should be equal to negative 3. Therefore, y equals to mx plus c. So y equals to negative 3x plus c. And we know that the point is 4, 3, so we're going to substitute that point in to find the equation of the normal. So 3 equals to negative 3 times 4 plus c. Should find that c equals to 15. So therefore y equals to negative 3x plus 15. Okay. And right here, for this point, when it intersects the x-axis, that's when y equals to 0. So we're going to substitute y equals to 0 to find our x value. So 0 equals to negative 3x plus 15. Therefore, 3x equals to 15. And therefore, x equals to 5 should be our final answer for this question. Okay, x equals to 5. And that should be a merit level question. In terms of getting an achieved, you should be finding achieved. So achieved could either be correct derivative, maybe a correct derivative might get you an achieved, or perhaps NZQA might perhaps want you to find the gradient of the normal, that might get you an achieved, okay? So gradient of the normal might get you an achieved, or just finding the derivative might get you an achieved, so I'm not too sure there. Question D, the graph of the function y equals to 1 over x minus 3 plus x has two stationary points. Find the x-coordinates of the stationary points and determine whether they are local maxima or local minima. Right, so stationary points, once again, that's dy over dx equals to 0. So dy over dx is 0. And local maxima, so that's d squared, so that's the second derivative, is smaller than 0. And local minima is second derivative is greater than 0. Alright, so first things first, we've got to find the first derivative, okay? So first derivative, we can rewrite y equals to x minus 3 to the power of negative 1 plus of x. Therefore, dy over dx equals to negative 1 times x minus 3 to the power of negative 2 plus of 1, okay? So therefore, dy over dx equals to negative 1 over x minus 3 to the power of 2 plus 1. Okay, so I just let me check one more thing here. So minus 3 plus 1. Okay, so now we're going to substitute, we're going to make dy over dx equals to 0. So dy over dx equals to 0. So therefore 1 over x minus 3 squared equals to 1. So therefore x minus 3 squared times of 1 equals to 1. Therefore x squared minus 6x plus 9 equals to 1. And if we rearrange, we'll get x squared minus 6x plus 8 equals to 0. So therefore, this will give us x minus 4 times x minus 2 equals to 0. X equals 2 or x equals to 4. Alright, so now we need to find whether these are local minima or local maxima. So we need to find the second derivative, okay? So second derivative, we can find it by... So we have dy over dx equals to negative 1 times x minus 3 to the power of negative 2 plus 1, of course. Okay, so d squared of y, so second derivative, equals to, so negative 2 times negative 1 is just 2 times of x minus 3 to the power of negative 3. Negative 3, and then the 1 there's going to be a 0, okay? So 1 there's going to become a 0. So second derivative equals to 2 over x minus 3 cubed. Yes, okay. So d squared y over dx. So second derivative equals to 2 over x minus 3 to cubed. So therefore, second derivative, that equals to 2 over, so first for x equals to 2, sorry. For x equals to 2, we have this. Substitute 2 into the equation, so 2 minus 3 cubed. 2. That gives us negative 2. So therefore this is negative, so this is a maximum. And in terms of x equals to 4, we can say the second derivative equals to 2 over 4 minus 3 to the power of 3. This gives us positive 2, so this is positive, hence this is the minimum. Okay? And that's our final answer for this question, and this should be a merit level question. Achieved should be finding the two stationary points that will get you an achieved. Alright, the last question here. A curve has the equation y equals to bracket 3x plus 2 to e to the power of negative 2x prove that the second derivative plus 4 times the first derivative plus 4 times of y equals 0. Alright, so this question is just finding second derivative, first derivative, and plugging it all together in order to prove that 0. So all we need to do is really just find derivatives. So y equals to 3x plus 2 e to the power negative 2x, okay? If we expand this one out, we'll get y equals to 3x e to the power of negative 2x plus 2 e to the power negative 2x, okay? So therefore, we can find the derivative here, so dy over dx. So for this part of the equation, we have 3x, we have the x here, so we have to use the product rule, okay? So first, if we find the derivative of x, it's just 1, so 3 e to the power negative 2x, and plus of negative 2 times 3x, which is negative 6x e to the power negative 2x, plus of 2 e to the power negative 2x, okay? So dy over dx equals to 5e to the power negative 2x minus 6x e to the power of negative 2x. So that's our first derivative. So second derivative equals to negative 10 e to the power negative 2x. And for this second part, we also have x when you use the product rule. So minus 6 times of e to the power negative 2x. And plus of 12 e to the power of 12x, sorry, 12x. 12x e to the power of negative 2x, okay? So that should give us negative 16 e to the power negative 2x plus 12x e to the power negative 2x, okay? Just check if I've done everything right here. So 3x e to the power negative 2x plus 2 e to the power 2x, 3. Okay. Oh yes, I did actually make a mistake. I forgot to find the derivative of this one. Apologize. Okay, so that's actually not plus, that should be negative 4 e to the power negative 2x. Okay, my bad. Okay. Apologize for that. So that should be negative here. So this is, apologize for that. I thought I did something wrong, but sorry about that. Okay. So now we have negative e to the power of negative 2x minus 6x e to the power negative 2x. So now we can find our second derivative. That equals to 2 e to the power negative 2x minus 6 e to the power negative 2x plus 12x to the power e to the power negative 2x, okay? So this gives us negative 4 e to the power negative 2x plus 12x e to the power negative 2x. Right, so d squared y over dx squared plus 4 times of the first derivative plus 4y equals 0. So we have our second derivative, that's negative 4 e to the power 2x plus 12x e to the power plus 4 times of negative e to the power of negative 2x minus 6x e to the power negative 2x. And I don't have enough room, so plus 4 times of y, which is just 3x e to the power negative 2x plus 2 e to the power negative 2x. Alright, so this should give us negative 4 e to the power negative 2x plus 12x e to the power negative 2x minus 4 times e to the power negative 2x minus 24x e to the power negative 2x. And looking at the bottom here, so plus 12x e to the power negative 2x plus 8 e to the power negative 2x, okay? Alright, so this and this, that gives us negative 8 e to the power negative 2x. That cancels with this positive one, so that those three will cancel each other out. This one will cancel out with this, okay? So this, therefore, this will give us 0, okay? So that's our proof there. So if you can finish the proof, you should be getting an excellence level grade. So that's our excellence level grade for the proof. First derivative should be an achieved. Second derivative should be a merit, okay? So first derivative and second derivative will get you a merit. And at least that should be how it goes, okay? So thank you for watching this video. Hope you enjoyed, and I'll see you all in the next one.